Over more than 20 years, over 2 decades, Java has continued to bring value to developers and enterprises worldwide. Thoughtful evolution has helped Java grow into the most vibrant programming language on the planet. Moving forward, we want to ensure that Java is well positioned for modern development and growth in the cloud. And our next speaker is uniquely qualified to talk about how Java's future direction will help you through this transition. He was a lead developer on AWS at its inception. And he led development at Joyent for just long enough to have been cured completely of any Node.js religion. He came to Oracle then, and he architected the bare metal cloud. And now he leads overall strategy for Java and the cloud and container native. Please put your hands together and help me welcome Mark Cavage.
All right, thank you, all of you. Thank you, George. Thank you, Intel. We are super excited to be here. Java and JavaOne really are by you and for you, and we have a ton of stuff to talk about. There's a lot of new content, a lot of fresh faces, including mine. And we're going to talk about the future, as George said, right? Because those stats that he put up, they're fantastic, but they're today. We need to be building for tomorrow. And actually, even if we take an honest look at where we are today, right, we can apply that actual famous Redmond quote that we all know and love, right? When web companies grow up, they turn into Java shops. That tells us something, though. It tells us that people are writing in something else first and rewriting in Java. We need to change that, right? Maybe it's Node.js, which apparently you can be reformed from. Maybe it's something else. But we didn't want the next decade to be Java first, Java always, right? That's how we want you to think about it. So we're going to talk about how we're going to get there. So there's 4 themes we're going to come back to again and again throughout this keynote, and really that we're going to use as guiding principles for ourselves in the Java group. Number 1 is openness. Right, this is self-evident to technologists. Transparency is important in today's world. It's more important than ever. And actually, we're just going to show you about this. We're not going to talk about it that much. We need to evolve. Evolution is actually really hard, right? It's very easy to add things. It's hard to change things. It's nearly impossible to get rid of things, but you have to do it, right? The use cases that existed 22 years ago aren't relevant today. The things that exist a year ago may not exist next year. So we have to change. We have to get there really quickly. We have to be nimble as we do this, right? When we get things wrong, we have to get it right. We have to get it right quickly. Last, we need to continue to scale, right? And scale is easy for us as engineers to think about, right? It's petabytes of data, or requests per second, or number of JVMs that you manage. But it's also about people, right? George had up that there are 12 million Java developers out there, which is awesome. But tomorrow, we want there to be 1 billion developers. So that's the world we need to be building for. Let's talk about how we're going to get there. Start with Enterprise Edition. Right, this is huge news from us this year. 8's here, brings you modernization of the platform. There's amazing stuff in it. HTTP 2.2, async APIs, reactive APIs, helps you modernize the platform. But that's not good enough. Right? We actually need to do a lot more to modernize, to get you to that world of cloud and microservices and serverless. Because the reality is EE is the bedrock of mission-critical systems. It does power enterprise. And if we look at why it's not getting us there, actually, if we apply those themes, it's actually pretty self-evident, right? Is it open? Well, no, it's a vendor consortium. Last I checked, those aren't that open. And is it nimble? Well, it shipped 4 years ago. That's not very fast. So we're going to change everything about this, right? We put out this news a few weeks ago. People have been very, very receptive to it. We're super excited about it. We're fundamentally opening up Java Enterprise Edition. Right. Cool. So we're moving into the Eclipse Foundation. Right, and we're going to change everything. We've actually gotten a lot of questions about this. I don't think people are quite clear. It's going to be everything, right? The reference implementations, the TCKs, that was a huge one people didn't expect. Authorship of specifications, importantly, control. We're going to be heads down over the next few months, getting to a 1.0 release there. But it's going to be, that's going to be a new day for it, right? That's going to set it up for the next decade to help us modernize. But I want to make sure you don't just hear this from Oracle, right? You've heard this kind of stuff from Oracle before. I want to make sure you hear it from all of our partners, right? So what I'd like to do is bring out 3 of the leaders of the EE community along with us. You hear all of us saying this together. So please welcome David Blevett from the Tomi Tribe, Ian Robinson from IBM, and Mark Little from Red Hat. All right. Thank you guys so much for being here. So we'll kind of do this as panel style. So we all, we all say it together, brothers in arms. David, let's start with you. Right, so you've been in open source for over 20 years. You built a fantastic career, a fantastic company out of it. What's your perspective on what this change means to the community at large?
Well, I think that when you look at our industry, we're filled with so many passionate developers, some of them quite young. The thing that I can't help but take away is you're inheriting EE. And so in a very real sense, EE for J is EE for the next generation. And the other thing is, collectively, you make the biggest investment in EE, which far exceeds what we collectively put in it. And so you having access to the TCKs, that if you have a problem, you can go straight to the tests and get them improved. It raises the bar on us. So this effectively makes our largest investors enabled to fuel EE, and we can all go faster, I think, in the end.
Awesome. All right, so Ian, IBM, obviously one of the largest vendors, probably one of the 2 largest vendors of Java and Java Enterprise Edition on Earth. What's your perspective on what this means moving to the Eclipse Foundation?
Well, the Eclipse Foundation, I think, is a good choice. It's the one that IBM picked, for example, when we open sourced our J9 Java virtual machine. We've had, it's called J9, but it's actually been IBM's JVM since the Java 5 days. So I think having both the low-level JVM and the Eclipse and the enterprise platform both at Eclipse is a really strong endorsement for Java development top to bottom at Eclipse. And I think there's a couple of advantages, I think, that this has to people from a couple of different perspectives. David already mentioned the TCKs, access to the TCKs, which is great for developers. But for people building solutions on top of Java EE, I think having this new community fired up with energy, I think it gives them encouragement. I think that the future of Java EE is strong. And I think the only word of caution I would have is that having just open sourced OpenJ9 and our enterprise Open Liberty runtime, that took us a lot of work. That took us a year to get us there. So there's a lot of work ahead, but I think we're going to be successful.
There is a lot of work ahead. We have a lot to do. All right, so Mark, Red Hat, obviously instrumental in creating MicroProfile, along with these guys on stage, a lot of people in the community. What's your perspective from MicroProfile and Red Hat on what this means?
I mean, you're right. We created MicroProfile over a year ago, moved it to Eclipse. We've seen a great groundswell in interest and participation since we moved it to Eclipse, for the very reasons that you mentioned earlier, that we can be more nimble and we can react to changes a lot more quickly. Moving E4J to Eclipse, I think, allows these 2 big communities to come together and help to drive enterprise Java into the next decade, as you mentioned earlier.
Awesome. OK, so what I want to make sure you all understand with all of us on stage is, please come participate, right? We cannot do this alone. It cannot keep being a vendor consortium. So the charter's open at Eclipse Foundation. Please come check it out. There's a mailing list. There's a Twitter Foundation. There's a panel, which I'm sure will be action-packed right after this. Importantly, stop by the Red Hat booth, the Tomy Tribe booth, the IBM booth, the Eclipse booth, the Oracle booth. Please come talk to us. Please come participate. All right, thank you guys so much for being here.
Yeah. Thanks.
All right, so let's move on. Let's talk about Java SE. Right, so 9 is here. 9 is a transformational release for us. Right, it brings you over 150 new features, streamlines the JVM. Importantly, there's a lot of support in there for things like Linux containers, gives you better management, honoring of C groups, memory settings. Also, it has modules, which I'm sure you might have heard about. And modules really are this amazing thing that are going to let us turn the corner and let us evolve. Right? For you, they mean you can get just enough Java, just enough JVM in your life. You can right-size the JVM. Very important for a cloud world, for a dynamic world. For us, that means we can finally evolve the platform in ways we could not do before. We literally couldn't. So we think modules really are this linchpin that's going to get us to that future. But again, is Java 9 enough? No, it's not. Right? If we apply those themes again, let's look at those. Right? Let's talk about openness first. When I came to this group, what I was told was OpenJDK, that's a place, not a thing. That's not open enough. So now OpenJDK is a thing. Going forward, we're going to be producing OpenJDK binaries under the GPL license. You truly now have a free and open Java that you've never had before. That's number 1. Number 2, you might be saying, well, the OpenJDK, the Oracle JDK, one of those is better than the other. Maybe I have to use the Oracle JDK. Today, that's true, right? The Oracle JDK has commercial features in it. These things power some of the most gnarly systems on the planet. It's amazing technologies for help you run Java at scale. But today, they're only available to an elite few. And for that billion developers, they need to be available to everybody. So going forward, we're going to open source all of the features in the Oracle JDK. There will be zero differences between the Open JDK and the Oracle JDK. That's. I got one more. Cool. So we truly now have an open Java, right? But it's actually still not enough because we think about pace, right? The last time it shipped was 3 years ago. That is not fast enough. So now that open, truly free Java that we just spoke about is going to come at you every 6 months, right? So now this, we think, actually starts to change the future of Java. This, we think, starts to put Java in the forefront of everyone's minds, certainly ours, but also people that are not currently writing Java. We think this brings it to a new future that has not previously existed before. So what I want to do, though, is make you not hear this from just me, not from Oracle. I'd actually like to bring out Mr. Java Renaissance himself, James Governor from Redmonk, to give you his perspective. James, come on out.
I only have one slide.
You only have one slide? All right, good.
I'm not going to have a next slide moment.
All right.
It's fine.
Thanks.
Hey, everybody. How you doing? Pleasure to be here. The last time that I actually stood on the main stage at JavaOne was back in the distant past, back in 2004. So who all was here in the Java ecosystem at that time? Yeah, I think there's probably some of you that haven't quite admitted that you've been around that long. But I stood here and I said something that was kind of contentious at the time. I said that the JCP was the worst form of governance for software apart from all of the other ones that we've tried. Now, it's kind of interesting. We've seen this long path. I mean, at that time, obviously, Sun was still around. Things have changed pretty dramatically. And in fact, what I think is interesting is that things have changed in the Java ecosystem probably more in the past 3 weeks than they have in the previous 13 years. This open source move, I think we really can't underestimate the significance of it. If we're going to have a chance for the community to flourish, if we're going to have a chance to really expand, I think, the ecosystem, it was necessary that Oracle took these steps. I think one of the interesting things that's happened over the past few years is the adoption of Java by the web companies. So first generation web companies, I mean, obviously Amazon, very much a Java shop. Google, tons of Java. Obviously, they have Go and other languages now. But what's perhaps more surprising is those web companies that said, look, actually, we don't like Java. We're going to be Ruby. And, you know, Twitter, we're going to do Ruby, we're going to do Ruby. That was until Ruby wouldn't scale far enough. They adopted Java. Facebook, again, they came out from a world saying, oh, no, we're not interested in Java, until they became one of the biggest Hadoop shops on the planet. So there's been a big change. But it's very, very important to those web companies that have an opportunity. They're all making open source contributions now. Things like in tracing, Zipkin. Across the board, we've seen contributions. Kafka began as a project from, again, LinkedIn. So the fact is that you've got large web companies that want to make contributions. They want to be part of this world. But they haven't really got involved with Java because it wasn't as open as they might expect. They also felt that it wasn't moving as quickly as they might expect. You know, they're coming from a world of continuous deployment. Well, if you tell me it's going to be 3 years before the next version, they're not so interested in that. You know, developers tend to have a certain degree of ADD. They want something new. They want something bright, shiny, and fast. So, I mean, one of the things is, as Java developers that you want to think about is, where do we go from here? I'm either new to the ecosystem or I've been around for a while. How relevant are my skills? So Redmonk, my company, we do a programming language rankings. That is every 6 months we do it. It doesn't necessarily change that fast, so we've kept it at that time frame. And basically what we do is we scatter plot the conversations in Stack Overflow against what's happening in GitHub. And it's been very, very interesting to us that at a time when a lot of people would say, oh, perhaps that Java was not as much a part of the new world you might expect, that it has performed with strength over time and continues. We generally see Java and JavaScript at the top of the rankings. There are tons of cool new languages out there. There's developers that are like, oh yeah, everything's going to be Rust or everything is going to be Go. Kotlin's this cool new thing in Java, but the simple fact remains that Java, the language, and not just the JVM, are a thing. So let's talk a bit about the JVM. I think, why did those web companies decide that they needed to adopt Java? partly because of the skills. There are so many skills available. If you're hiring people out of computer science, chances are high they've got Java skills there. But it also gets back to something that it's all very well and good to talk about, move fast and break things, but who likes to sleep throughout the night? There you go. So I have 3 kids, and so I've had various times in my life in which I don't sleep through the night. But generally, you want something you can rely on, something that's stable. And what those companies found was that, in fact, in terms of observability, performance, traceability, and just the ability to manage something over time, Java and the JVM had a real value. There isn't really anything out there that replicates the power of the JVM today. So if we can accelerate the language development and begin to make it more like the modern developer expects, and that's what the challenge is for Oracle, then there's plenty of runway to go. And I think that's the lesson. It was very important that the open sourcing happened. And we've got a new version of Java coming out, and that notion of a 6-month cadence is going to be a big, big deal. So hopefully in a couple of years, we'll be here. We will have had the low-hanging fruit done and a lot more development in Java, the language. Thank you.
Thanks, James. All right. It's actually super validating for us to hear that. I hope you're as excited about the future of Java as we are. What I'd like to do now, after hearing that from James, is actually move on a little bit and talk about cloud, right? Talk about Java in the cloud. As George said at the very beginning, there's 55% of JVMs today are connected in the cloud somehow. We need to build for a world of 100%, right? That's tomorrow, because cloud's pervasive. It doesn't matter what you work on, cloud is in your life if it's not already. Now, you come to conferences like this, or open world, or technology conferences in general, you're going to hear a lot about the business value of cloud, right? Things like OpEx and CapEx and elasticity. And all those things are true. Let's talk about what it means to developer, right? Because this is a developer conference. To me, when you boil it down, cloud is about building a distributed system at the end of the day, right? And those are hard. They're actually super hard. It changes the way you have to think. It changes the way you have to tool. It changes the way we build, deploy, scale, operate our services. And so what I'd like to do is actually talk to you about what's in the ecosystem and what we're going to do in Java itself to help you in the cloud. What I'd like to do is make sure that we have a common frame of reference for this, right? Talk about one of those hyperscale web companies that James mentioned, that we all think about. So they've never been at JavaOne before. They're a new face, as I said. There's going to be some fresh ones of those. But they're going to come talk to us about their architecture, the challenges they faced, what was hard, what's still hard, and importantly, why they've used Java. So please welcome to the stage Nicholas Gustafsson. He's the principal architect at Spotify. Thank you so much for coming, Nicholas.
Thank you very much. Hey, thank you very much for having me. Spotify is a music streaming service. We aim to provide our users with the music they love on the platforms where they exist. Platforms that might include the ones you see in the picture here, but also embedded platforms like TVs or PlayStations or stereo receivers. We also want to give our users the features that they want in order to be able to discover and listen to the music they want. Since we launched in October in 2009 as a small Swedish startup, we've grown pretty quickly, and we're now in 61 markets around the world, having most recently launched in Thailand. We're at more than 140 million active users. But if you ask me, what I think is even cooler than that is that we handle more than 3 billion streams per day, and we have more than 4 million requests to our backend per second. Now, dealing with this scale turns into a pretty interesting and challenging technology problem, as you might imagine. Spotify started out as a Python backend. And you already met James, and you heard Mark mentioning this quote of his, and this is very much true for Spotify. While Python was an awesome way for us to get started and to build out our backend as we were a young company, we ran into some pretty constraining scalability concerns. We had one service, though, at the time that was implemented in Java. It was our search service. It's actually still around. We noticed that during the scalability incidents that we had, it behaved in a much more stable way than many of our other services. And the JVM had this nice property where we could actually observe what was happening in runtime. If that was collecting runtime metrics on the platform itself, or if that was profiling the service while running in production, both were very effective ways of knowing what was actually happening to the service. One of the very early and arguably the best decisions that we've taken architecture-wise has been to design our backend as a set of small, single responsibility, share nothing services. The pattern that is now known as a microservice architecture. As we decided to start exploring Java and a little bit later moving over to Java, being able to do that incrementally, service by service as it made sense, was a crucial way for us to be able to do that change. Having small services also means that we can, as humans, easily understand and reason about them. We can scale them independently. Different features at Spotify has very different interaction patterns, and the services that powers the features needs to be scaled in different ways. It also means that we have limited impact when we actually have failures. So a service might fail for whatever reason, but only a subset of the feature set of Spotify or only a subset of our users might notice. Like if the search service would fall over, that will only affect search functionality on Spotify, not streaming or playlisting or whatever might be the case. And lastly, it enables us to have ownership of a service firmly within the team that builds that service. So you run what you build, and that closes that important feedback loop in between developers and operations. The picture on the right in this slide shows a very high-level view of our architecture. You can see the perimeter services, which are exposed to the internet. They're very hardened, and they manage things like authentication of requests to our backend and will route requests down to services further down. The next layer is what we call the aggregation layer. This is services that deals with things that are very close to what you would see in our clients, a one-to-one representation of the views in our clients. These services are stateless, and they don't do anything on their own, so they fan out to the lowest layer where we have services that do the actual data processing and storage. Then as responses get back, the aggregation services will create the view that we serve back to the client in a format that is easily consumable by our clients. All of this runs in a complete clone in multiple data centers around the world for us to be close to our users and have low latency, but also to be able to do full data center failovers during large-scale maintenance or incidents. And this is something that we do actually fairly frequently. We're not only using the JVM for our backend services, we also use it for our data processing and machine learning. Our data processing framework is based on Scala. It's called Geo. It's been open sourced. It's a way to build pipelines that run on top of Google's Dataflow and BigQuery cloud products. We schedule these using another open source framework called Styx, which is a Docker scheduling framework. And this has enabled, similar to what I described from our microservices, for us to scale data processing and machine learning to the scale that we're at. So this is a logical equivalent to our microservice architecture, but for data processing. If any of this tickles your interest, I'll be running a session in just a few hours, so feel free to come along if you want to hear more details around how we think and build our backend services. And thank you very much.
All right, thank you so much, Nicholas. So if you've been in the space for a while, if you've been working on cloud systems for a while, you see that like an architecture of the sneak peek that Nicholas gave you, you realize we all have the same problems, right? We all have to build effectively the same thing to solve that same challenge again and again, right? We need this thing that helps us get a distributed kernel, a distributed substrate. And if you don't already have one, and you're asking what should I build, or you have one and it's long in the tooth, and what should you do next? Our opinion at Java, our opinion at Oracle is you should use Kubernetes. Right? It is the right open source building block that abstracts away clouds, abstracts away infrastructures, gives you this distributed substrate to help you build resilient microservices. We're taking a big bet on it. We've put a lot of people on the Kubernetes project. We announced several Kubernetes-focused cloud products earlier today on the other side of the fence at Open World. We're doing a lot with it. We actually think it can do a lot for Java, too. So what I'd like to do is have you hear from a subject matter expert on Kubernetes why this is right for Java developers, why this is the platform you should build microservices on. So please welcome Craig McLuckie. Craig is the CEO and founder of Heptio. Heptio is a startup focused on bringing Kubernetes to the enterprise. But what makes him an expert is Craig was actually one of the co-founders of the Kubernetes project during his time at Google. So Craig, thanks so much for being here. Stage is yours.
Well, thanks so much for having me here, folks. It's really been an exciting 3.5 years since we started the Kubernetes project. And what we set out to do back in the day was to bring a lot of Google sensibilities around building and running applications to developers like yourself. I personally was really inspired by the idea of providing a better framework to run applications so that developers can focus on code and expert systems underlying the application languages could deal with a lot of the mundanities and challenges associated with running those applications. When we set out to start this project, we knew it wasn't enough to just write a letter from the future to enterprise developers. We knew that we needed to create something in the open and make sure that it worked as well with relatively traditional workloads as it did with the forward-looking, progressive, dynamic workloads that ran inside a company like Google. And so Kubernetes over the last 3.5 years has emerged as pretty close to a standard, and it is an open source container orchestrator. So for those of you who aren't familiar with it, it's worth just breaking down those 3 words. Open source obviously is critical. It's becoming increasingly important to organizations of all sizes. As they're making decisions about the technologies, they know that open source provides both an incredible force in terms of driving innovation, but it also buffers them from vendor lock-in, which is increasingly important. Containers have become an amazing way to simplify the operations process. As you're building applications, they provide a hermetically sealed, highly predictable unit of deployment. So you can take your application, in this case a Java application, package it up with all of its dependencies, and predictably deploy it out into a variety of environments, effectively decoupling it not only from the environment where it's running, but also in some ways from the operating system that it's running on. And that creates very high levels of portability. And then orchestration is the final piece. And this is where much of the magic is. By using a dynamic orchestrator, you can rely on an intelligent system to deal with all of those operational mechanics, deploying, scaling, monitoring, and reasoning about your application. Now, what this means to the Java community is actually pretty significant. If you think about the old world, you'd have middleware that would be responsible for running your mission-critical enterprise applications. What we're starting to see is that middleware getting teased apart, almost polarized into 2 different pieces. We're starting to see the emergence of systems like Kubernetes as a standard way to run a lot of the underlying distributed systems components, effectively stitching together a large number of machines that can operate as a single logical, ideal computing fabric. And then what we're starting to see is a lot of the other functionality getting pushed up into application-level libraries that provide a lot of the immediate integration that you need to run those applications efficiently. An outcome of that is pretty significant in that it now opens your Java applications up to a polyglot world. They can coexist side by side with applications in other languages if you want. But more importantly, it opens up them to an heterogeneous world where you can interleave these Java applications with a lot of dependencies that they might rely on. So you could run a Cassandra database, for instance, on the same core infrastructure using the same underlying orchestrator that your application uses, which is very powerful. What that means at the end of the day is that as you have a lot of enterprise concerns like governance, risk management, and compliance, you can rely on a simple, single, consistent underlying framework to deal with those problems for you. And as a result, Kubernetes is effectively creating this distributed systems operating system, a natural environment where you can run not only Java applications, but anything else. And you can do that in a way that is perfectly decoupled from your cloud provider. It works just as well on-premise or in the cloud. Gives you a great degree of choice and flexibility around where you want to run those applications. Now, as we look to the future, there are a set of challenges that exist. when you're starting to move away from relatively traditional, large structured applications into this more modern microservices-based environment that Kubernetes naturally pushes you towards. The first and foremost of those is the weight of Java. If you want to move into this environment that is intrinsically more bite-sized, it makes sense to have a more bite-sized runtime environment. And it's very heartening to see some of the work that's being done to reduce the weight and spin-up time associated with Java so that you can actually get these more dynamic applications running. Another result of that intrinsic dynamicism is the need for higher levels of introspectability. You start to live in a world where your JVM, your Java application, is no longer tied to a single physical machine. So to really understand what's happening and to be able to diagnose things in these new worlds, you need higher levels of logging, observability. You need to have access to structured information about the application so you have a better sense of what happened after the fact without necessarily tying that to a single physical machine. It's also heartening to see some of that coming out in this very conference. The third thing that I think a lot about as we look at this environment and the needs moving forwards is the libraries themselves. As I said, Kubernetes provides essentially a distributed system environment, an operating system for applications. And while it is relatively unopinionated, it does offer up a certain set of primitives that are necessary to allow an application to find another application, access it, consume it. And I would love to see over the coming year or two a lot of focus on making much more natural Java runtime environment integrations with the underlying Kubernetes substrate. The final thing that I think about a lot when it comes to the Java community is a little bit nuanced. When many people start looking at Linux application containers, they think of them largely as a replacement for a virtual machine, just a way to package up and run something. But if you look back at their origins historically, they provided a very robust and rich resource isolation framework, a way to tease apart the set of resources that would be assigned to something and allow you to pack very densely a number of applications onto the same set of physical infrastructure. And one of the most heartening things that I'm seeing coming out of this conference is a lot of effort to make cgroups integration much more natural into the Java runtime environment. So I'm very excited about the future of Kubernetes. I think it's a very natural environment for you to run your Java applications. If you're interested in learning more, I'd encourage you to go to the website, kubernetes.io. And if you want to get closer to the community, feel free to take a look at the Cloud Native Computing Foundation, which is a vendor-neutral home where the Kubernetes project and a lot of new cloud-native technologies are being honed. Thank you so much for your time, and have a good day.
All right, so if you're one of those enterprises that needs to get some Kubernetes in your life, call Craig. Before we move on, what I'd like to do is give you some helpful information about how to get started with Java and Kubernetes. We put this together. So Oracle acquired them earlier this year. It's a fantastic container-native CI/CD service. Lets you get some containers in your life. Importantly, get some Kubernetes in your life. It's where we've launched all those Kubernetes services I mentioned. We've actually put together a curated set of Java getting started guide, tutorials, quick steps, libraries to help you get some Java into containers and into Kubernetes. So, by the way, there's a community edition, completely free, no strings attached. There will never be strings attached. So hopefully you find it useful. If not, let us know. If so, please let us know. All right. As Craig said, he spoke a lot at the end about observability and operations, which I think that's what we should talk about next when we talk about cloud services. Right? Because operations are fundamentally hard. They're one of the hardest parts of building distributed systems. And importantly, if you don't already know this or if you've never done this before, operations are actually part of your product. They're literally part of your service, and you have to think of them that way. Now, importantly, though, like observability, we always need more information. We need more insights, right? We can never have enough. Right? We have tons of data, but we need real-time information. As I said at the beginning of this talk, that we're open sourcing all of those commercial features in the Oracle JDK. One of those things happens to be Java Flight Recorder. If you're not familiar with JFR, JFR is this amazing, like, super Swiss Army knife that lets you diagnose any JVM or any Java application, right? You can see in real time what's happening up and down the stack. And you can do it with no performance overhead. So it's fantastic, but we need to help you scale in the cloud. We need to help you with this in the cloud. So what I'd like to do is actually give you a sneak peek at a service we're building in the cloud to help you manage JVM to scale, help you give you real-time diagnostics. So please welcome from my team, Varun Madden and George Matthew, to talk about this.
Thank you, Mark. We're super excited to be here today and share with you all a service that we've been building for a while now. The service is focused on making container-native development in Java simpler, debugging any issues that you guys run into much easier, and just helping making your applications more performant. I'm sure almost everyone over here had to deal with profiling applications. And Mark kind of referred to this. Java Flight Recorder makes this really simple for a single JVM. But the problem grows as we move to the cloud, and even more to microservices, as we all are doing right now. The issue is no longer just what is my performance issue, but we need to know when it's happening and where exactly is it. So I would like to introduce a container diagnostic service that helps you do exactly that. This service runs in production, it's always on, provides real-time data with very, very low overhead. It gives you the depth of data that JFR provides and the breadth across the service. George here will actually give you a live demo of the service now.
Cool. Thank you, Varun. There's my screen. So a quick note about the setup for this demo. I have 3 replicas of my service running on a Kubernetes cluster, with the diagnostics service gathering continuous JFR recordings of my service. Now, one thing I'd like to reemphasize that Varun already touched on is that this diagnostic service is a very low overhead service that's designed to be running continuously in your production cluster. Because like he said, you don't know when the problem's going to show up, where it's going to show up, or that you even have a problem. Now, JFR has a lot of very useful and deep data, but today I'd like to focus on the issue of memory leaks. So if you look at this graph up above, it shows you memory usage by each of my pods right after garbage collection. And it looks like 2 of them are doing OK down here, but one of them's having a little too much fun and using up more memory than it should. Probably means it has a memory leak. Now, we do a lot of interesting analysis on this data that we gather from JFR so that we can find the problems for you and you don't have to go looking for them. So let's go look at this analysis tab to see what we found. And aha, we did find a memory leak. And as we suspected, it's only affecting one of our pods. JFR has this cool new feature that tracks the lifetime of a sample of allocated objects. And using this data, we can tell which objects are hanging around in the JVM for longer than they should. So let's dig in and see if we can pinpoint the source of this leak. It looks like in this case, we have some samples of a byte array hanging around for longer than they should. And if we click into an individual sample, we get very detailed information. We get a stack trace showing us exactly where in our code this object was allocated, and a reference chain showing us the chain of references that's preventing this object from being garbage collected. So let's go look at the code. So it looks like line 63 here of my leak, appropriately named leak work item class is where I allocate this object. Let's go to line 63. Right there is where I allocate the object. No surprises there. Let's go back to the reference chain. It looks like this hash set right here in progress items is where I hold on to these references. And if you look closer, it looks like I do add these objects to the hash set and remove them. But it turns out that I forgot to override equals and get hash code in this class, which is causing the leak. Now, if you've ever had to troubleshoot a memory leak issue in production before, you know how incredibly difficult that can be and how much easier this is. And this is just the tip of the iceberg when it comes to the power of JFR. And we're excited to bring you all of that power to troubleshoot your production systems. Thank you.
Thanks, George. This was just a sneak peek of a small little thing that we demoed over here. If you guys are interested, there's a much more in-depth session tomorrow morning, 8:30. I know it's early in the morning, but believe me, it'll be worth your time. Thanks, everybody.
Thank you.
Cloud, which is serverless. Right? It's on everybody's mind today. And if you're not familiar with it, serverless is this compute abstraction that takes away all notion of infrastructure from you as a developer. Right? It applies to many things. It applies to compute, to databases, to storage. But importantly, when we talk about applying serverless to our code, to what we deploy, we think of it as functions as service. Right? And it's kind of a beautiful model, right? Because it lets you focus purely on the logic of your code, purely on business logic, not worrying about infrastructure, not worrying about that like muck that's in your system. And importantly, it gives you an amazing economic model too. But again, having worked in the cloud space for a while, you look at this, and honestly, where we are in the space of the industry is actually pretty nascent, right? What's out there today is literally triggers for the cloud. right? Every cloud provider's got one of these things. Something like a VM goes up, a VM goes down, it publishes an event to a bus, you get some code that executes, you can take some action. It's super helpful, it's amazing for that use case, but it's easy to be tricked into thinking that's an app dev platform when it's not, right? The fundamentals of computer science are always with us, right? Things like concurrency and synchronization and state management, these are hard. For any reasonably sized application or reasonably sized microservice, you need something better to do that. What you need to solve those problems is what Java was invented for in the first place, right? You need a language. 22 years ago, Java solved this problem. It's why it is where it is today for running on top of an operating system, whether that was Linux, Solaris, Windows, whatever. When we talk about the distributed operating system, right, that going to the cloud, we need a language to help us with those problems. So we're super excited to talk about what we're doing next. Right, we're going to talk about an open source project we're creating that is container native, completely language agnostic, but there's importantly an exciting Java layer that we're putting into it to solve those problems. So what I'd like to do is turn the stage over to Chad Aramura from my team to talk about what we're doing. So Chad, the stage is yours.
Thanks, Mark. My screen. I am super thrilled to introduce to you the FN project. The FN project today consists of 3 components. Number 1, the FN server. The FN server is the foundation of your functions as a service platform. It's what enables developers to build, deploy, and scale functions in a multi-cloud environment. It runs locally on your laptop, so you can get dev prod parity working locally, both in the cloud. It's fast, scalable, and container native. Number 2, we're announcing the FN Java FDK, or Function Development Kit. The Java FDK allows you to easily bootstrap your Java functions. It gives you a data binding model to bind the input to your functions to common Java objects and types. And finally, we're announcing the and finally, it gives you a test harness to test all of your functions using JUnit rules. So I don't want to forget that. And finally, we're announcing FN Flow. Flow is a system that enables developers to build higher-level workflows and orchestrate your functions in a more complex environment. You get things like sequencing and chaining, parallelism, fan-in, fan-out, error handling, state management, all from the language of your choice. Today, of course, we're announcing that Java is the first officially supported language. That's actually what I'm going to demo today. So in order to show this, we built a demo app called Vista. If you look at this application, it consists of 5 functions. And basically what it's doing is pulling images from Flickr of cars, detecting the license plate on that car, getting the actual value of the license plate using the OpenALPR library, which is an open source library. And then it uses OpenCV to draw a box around the license plate and send all of that information to both Twitter and Slack. As you can see, we have a number of red arrows here. And those are no-nos. That's where we have hard-coded invocations of each function from the previous one in order to call them. It's almost an anti-pattern when it comes to microservices and functional development. Enter FN Flow. FN Flow gives us a programmatic way to remove those hard-coded invocations and move them into their own function called a flow function. What we've done is decoupled all our functions from each other, and now we're back to the proper architecture for functional development. Let's take a look at some code. The first thing we'll notice here is that it's short, sweet, and simple. It's really a great thing. If you look at the top, we have our scraper that we invoke. It's a little lag here. Once we invoke the scraper, we get back a flow future object. That flow future object implements the standard completable future API that was introduced in Java 8. Along with that API comes a number of promises-like methods that gives us all the nice workflow that we want, such as then compose. Then compose adds steps to the compute graph and returns a future that represents the completion of those steps. Once we do that, we get basically the nice fan-out capability that I talked about before. So then we fan out, and we run the plate detection, and we also run draw. And once we're finished with that, we run all of, which gives us both the Twitter and the Slack function, which posts to those. And when it's complete, we have a whenComplete method, which then tells us whether it was successful or it failed. That's actually something that I had no concept of before in the first version of Vista, because we had no concept of a complete workflow. So a couple things I want to point out. Of course, this looks like a single Java program. In fact, it can be reasoned about just like a single Java program. We can test it. We can use JUnit. We can put breakpoints. We have our familiar IDE. It's a single function code base. But behind the scenes, it's being broken up into sometimes hundreds, if not thousands, of function invocations. In fact, every step is a different JVM that we're running in a massively parallel environment. So you get all the benefits of a functions as a service system, such as the economic model of only getting charged for the milliseconds that these things are running, massive parallelization, and also the operational benefits without the complexity of dealing with a functions as a service system. And one other thing to note, any variables that were created inside the enclosed scope, whether part of the heap or the stack, gets reconstituted in all future invocations of any functions inside that scope. So it's a very powerful concept that no other workflow system gives you today. So I quickly plugged in the internet right as I came on stage. So we're going to see if I have internet. But we're going to try and run a demo. Yeah, I was on the Wi-Fi before. Don't ask me why. So if you look here, all I have is a simple payload.json file. It's just your standard JSON, 3 input variables, license plate, car USA. We're going to pull 20 of them. And because FN, the functions actually take standard in as their input, it's very, very simple. I can actually take that payload, and I can pipe it right into FN call. FN call is a wrapper around curl, which hits the server, which in this case happens to be running locally on my machine. And then my app name is my app, and it's flow. So once it starts running, the first thing we'll notice on the left is a number of functions are starting to spin up. We see that we already have a couple running. We have a number complete. And in the middle, this is the flow UI, which shows here, I'll make this big, which shows the fan out. So at the top, we have, let's make this bigger. We can see now we're starting to fan out. This is a visual representation of all of the functions that are being sequenced and ran from each other, including a nice fan out capability. If I click on any particular node, for example, this one, I can actually view the entire call stack of how this particular function was called. This is really extremely powerful. It was composed from detect plates. Here's the log that I got from detect plates. I can view all the way down to the scraper, which is what the first function is in our sequence, all the way down to the flow function. And if we look on the right, of course, it's already finished. I wasn't able to show much, but we get all of our images in Slack, and finally, it's finished scraping. So I know this demo is extremely fast, but I hope that you got to see just a sense of how powerful the FN project can be and why we're so excited to announce it to the Java community today. Thank you.
So Chad, before you walk off stage, I actually have a question. This is going to be open source, right?
That's the plan, Mark.
Is it open source right now?
It isn't.
Well, it probably should be. Like, we're JavaOne. I say we do it.
Let's do it.
All right, open source the FN project right now.
Oh, there it is.
Here we go.
All right.
It's like we knew this was going to happen.
Well, I'm in the danger zone. All right. Hopefully my two-factor auth is off. Oh, no. Wait. Don't worry. That's an advertisement for 1Password. Boom. It's open.
It's open source right now.
Thanks.
All right. So please go try it out. We're really excited about where this is going. fnproject.io, by the way, if we didn't say the name. So please come try it out. Please give us feedback. Please come participate in it. Now, one thing I want to say about this, like the last thing I want to say on this, Chad showed you this demo. It's a super amazing demo. I get chills every time. But he talked about the completable futures API, right? And I think the way to think about this is, think of this as like a V1, right? This is our first step. When we talk about setting up Java for the next decade, imagine what we can do when we actually apply the language to this in a much bigger way, which is actually an excellent segue to the next of our talk. So what I'd like to do is now transition to talking about where we are with Java 9 and the VM, and where the language might be going. And who better to do that than the one you know and love, Mark Reinhold, the chief architect of Java. Mark, come on out.
Thank you, Mark. Hello, everybody. Welcome to JavaOne. Java 9 is here. That means, that means that Jigsaw is here. I heard those boos. In Project Jigsaw, we set out 9 years ago, believe it or not, to solve 2 fundamental problems in the Java platform. One is the brittle and error-prone class path. The other is the massive and monolithic JDK. These two fundamental problems, we address both of these problems together by employing our standard recipe for evolving the platform. Identify the missing abstraction. Figure out what it ought to be. Add it to the platform in a way that fits it well with everything else that's already there. And of course, while doing that, preserve Java's key core values of readability, simplicity, universality, and compatibility. For these two problems, the missing abstraction, as we all know by now, is modules. What is a module? Well, it's actually pretty simple at a high level. A module is a set of packages designed for reuse. In Jigsaw, modules are a new construct of the Java programming language. They work the same way at compile time and runtime because they're known to both the compiler and the virtual machine. This greatly simplifies development. You declare a module in a module declaration. It's a little bit of Java code. You give your module a name. You name the packages that it exports for use by other modules, the modules that depend upon it. And you name the modules upon which it depends, whose packages it will use. Where do module declarations go? Well, they're Java source code, so they go in little Java files. By convention, these are named module-info.java files. What do we do with .java files? We compile them. You compile one of these files, you get a little class file. The use of class files here is intentional. It was somewhat controversial, but it's intentional because it makes it easy for existing tool chains to adapt to this new world. To package up a compiled module for distribution, all you have to do is make sure that the module info.class file is in your jar file, right there at the top level. Then you have what we call a modular jar file. So the module system helps escape from class path hell because it provides a cleaner and safer alternative to the class path. That is the module path. When you put modular jar files on the module path, the module system can guarantee two key properties when you compile or run your code. These are properties you can't even express on the class path, much less ask to be guaranteed. The first property is reliable configuration. Reliable configuration means if one module requires another, then that other module will be present, and none of the modules present will conflict with any others. As an example, here we have our module confu.lib again. Note the use of reverse DNS for the module name. That's a convention we're trying to establish. Confu.lib requires a module named confu.util, so the module system goes off and finds it and establishes the proper connection between them. Now suppose the confu.lib also required some other module called confu whatever, but there is no confu whatever. Well, what happens when you try to compile this module? At compile time, you get an error message. Error, module not found, confu whatever. If maybe confu whatever used to exist, but now it doesn't, at runtime, you'll get an exception. Module confu whatever not found, required by confu.lib. The second property guaranteed by the module system is strong encapsulation. Strong encapsulation means that code outside of a module can only access the classes and interfaces in the packages explicitly exported by that module. This means you can conceal your internal APIs and change them whenever you want to. To continue with our example, suppose there's some code in confu.lib that instantiates some secret internal class in the confu.util module. Well, you try to compile that, you'll get an error message. Sorry, that's not accessible. If you somehow manage to run it because maybe confu.util used to export that package, but now it doesn't, then you get an exception, illegal access error. And note, in these exception messages, we put a lot of information to help you diagnose what went wrong. So reliable configuration, strong encapsulation, this is a much saner world than the brittle and error-prone class path. The module system helps with the massive and monolithic JDK. That's because we've taken the module system and applied it to the platform itself. Starting with this spaghetti bowl of tightly coupled platform components, after years of painstaking refactoring, we managed to divide it into a set of 26 standard Java SE modules. I'd like to call your attention in particular to the Java base module there at the bottom. You might notice that there are no connections to the Java base module. I haven't drawn them in because every module implicitly requires the Java.base module. That's the module you always have to have. It has important classes in it like JavaLang object and JavaLang string. So all those connections aren't drawn, but base is always there. And of course, base does not depend on any other modules. The JDK, of course, has these modules plus many, many others, including modules for the standard development and debugging tools, service providers, and JDK-specific APIs. Since we have a modular platform, we now have modular JavaDoc, which I'd like to show you. There we go. So this is the front page of the Java 9 JavaDoc. To give you some guidance up front, this is divided into 3 sections: SE, the JDK, and JavaFX at the bottom. You can see it's organized. This front page is organized by modules, so you can go click around. Let's look at the Java base module. Here we go. There's the base module. It's got a bunch of the usual stuff in it. Java IO, Java Lang. All those important things. We can go back, say, and look at, what's another, well, no, not that. Let's look at a more interesting module, java.sql.rowset. So sql.rowset is a more interesting module because it depends on some others. We can see that here the packages that it exports, and then later on we have in the JavaDoc a specification of what are the additional modules that it requires in turn. And if you just want to learn at a glance what's going on, you can go up here, and there's a little hoverable thing here. You get an image that's shown you, and this is actually generated by the JDK build. You can zoom in on it if you like. That shows you the subgraph of the module graph for just the Java SQL Rowset modules. It means if you require Java SQL Rowset, you're going to get all of these others. OK, if we can go back to the deck, please. All right, since the platform is modular, it's now scalable. Most applications, after all, don't need all of these modules, and now we can reliably configure consistent subsets of them. For example, if we have a module that just needs the java.sql module, and whatever else java.sql happens to need, we can configure a custom runtime system that contains just those. All the other modules just fall away. We produce these custom runtime systems with a new tool in Java 9 called JLink. Java finally has a linker. It's an optional step, but it's a very important one. We can switch back, please. All right, so I packaged up a little demo here. Let's take a look at it. It's org open JDK hello, hello world. I know, very, very original. Let's take a look at the code. So this is a tiny little web application, about the smallest you could possibly make. Here's the main class, the only class, in fact. This uses the built-in ComSunNet HTTP server API. It's been in the JDK for a few releases now. Very handy if you just want to whip up a little app that talks to the web. I won't explain all the boilerplate here, but the important part is the method that makes the content. And in response to any request, doesn't matter what, it's going to build a little web page that says hello modular world, tells you what time it is, and gives you a list of the modules in the running image. So it's just using the stream API to get a stream of all the modules and then format them nicely. It uses the JavaSQL timestamp class just for amusement in order to show the time of day. Let's take a look at the module info. Here we go. Very simple module. It requires 2 others, JavaSQL, JDK HTTP server, and it doesn't export any APIs because, well, it doesn't need to. It's an application. OK, let's compile that. I've just prepackaged up the steps here to make it easy. Now we've got org open JDK hello.jar. We can look at that, and we see inside we've got just not only the traditional manifest, but our module info.class. OK, now I could run this directly, but what I'm actually going to do is run it in a Docker image. I'm going to make a little Docker image here. Here's a little Docker file that just runs this Hello World app on the class path using JDK 9. This is using the early access build of JDK 9 that you can get from Oracle for Alpine Linux, so it's more compact. Let's make that Docker image. Don't worry, the error message is normal. Goes off, it does the Docker thing, adds stuff, removes stuff. Da-da-da. Whoops. No. Let's run it. And let's see, if I go to localhost. Hello, modular world. This message brought to you by all those modules, only a handful of which were actually necessary. All right, so let's look at something, let's do something better. Let's link a custom image. This custom image will have just the modules that we need. So I'm using the Alpine Linux build, the JMods from there. That's what the module path up here is specifying. I add the modules that I need. I tell it just for amusement that there's a launcher command named hello, and I do some compression and drop the header files and skip debug information to make it small. So I've got a custom JRE here. If I look in its bin directory, it's got a little hello command along with Java and, well, Keytool because. And it's nice and compact, 33 megabytes, right? Whereas if I look at my Docker images that I just built about a minute ago, it's 266 megabytes. Ouch. Okay, so now I can make a Docker image containing just this. And that new image is a mere 38.9. Well, round up to 39 megabytes, and I can run it. And now we reload this page. Ta-da! It's just the subset of modules, only the modules that we linked in. All right, if we can go back to the deck, please. Okay, so the modular platform is scalable. And that's scalable in the technical sense, not the people community sense that Mark mentioned earlier. But it has additional benefits. Strong encapsulation means that we can conceal the internal APIs of the JDK. This makes the platform more secure by limiting the damage that malicious code can do. It improves platform integrity by ensuring that libraries and frameworks and apps don't depend upon the internals of the JDK. And finally, it helps make the platform faster. Link time is an excellent opportunity to do whole system optimization, such as resource compression, early verification, and ahead-of-time compilation, plus a whole slew of others. We've implemented some of these in JDK 9. There are more to come. We have a module system now and a modular platform. You might be wondering, well, what about existing code? Do I have to convert all my code into modules in order to run on JDK 9? No, you don't. Earlier, I described the module path as something that's better than the class path, but it is just an alternative. The class path is still there. In fact, the two can peacefully coexist. Jar files on the class path can even refer to APIs that are exported by modules on the module path. Okay, good. So the class path is still there. It still works. But you might have heard Jigsaw breaks everything. That's not true. Jigsaw breaks some things. Remember, one of Java's core values is compatibility. We took this extremely seriously in Project Jigsaw. That's one reason why it took so long. If an existing application runs on JDK 8, and if your code only uses standard Java SE8 APIs, then it will most likely work on JDK 9 without change. I said most likely here for a reason. There are some minor differences. We removed a few obscure, rarely used methods and mechanisms to enable a clean modularization of the platform. Otherwise, it simply would not have been possible. We deprecated these ahead of time in Java 8. Now, what if your code does use some non-standard or JDK internal APIs? And by your code, I mean not just the code that you write yourself, but the code in all those libraries that you downloaded from Maven Central over the years. What if those libraries use internal APIs or depend on other internals? If your code depends upon JDK internals, then it may require change. even though many of these changes are pretty obscure, they have affected some popular libraries and frameworks and tools. Happily, in many cases, their maintainers have already fixed them. I wanted to get an idea of what is actually ready to run on JDK 9 today. So I asked a question on Twitter last week. Do you maintain a popular Java library, framework, or tool? If it works fine on JDK 9, then please reply with its name and version. Thank you to everyone who replied. Here's a list. All of these things work fine on JDK 9. Probably a lot more stuff does, but these certainly do. There are some important things in this list. For example, all the major build tools, Ant, Maven, and Gradle are there. JUnit and TestNG are there. Essential libraries like Jackson, Log4j, Hibernate, ByteBuddy, and so forth. And the whole Spring framework itself, just released, runs fine on JDK 9. So I keep talking about internal changes. You might wonder exactly what do I mean? Well, let's look at a couple of examples. One is our old friend rt.jar. rt.jar is a zip format file. It's been in the JDK since 1.2. It contains all the internal classes of the JDK. This file no longer exists in JDK 9. It no longer exists because we replaced it with a file in a much more efficient format. And there was just no reason to keep it around. But there are a bunch of tools that read this. IDEs in particular use this to figure out what's in a JDK. So what we did was we provided a supported way to get at this information. There's now a NIO virtual file system at the JRT URI. You can open that up and grovel around in it, just like you used to grovel around in rt.jar. Another example is the Sun Security X509, X500 name class for manipulating X500 distinguished names. This has been around for a long time. There's actually been a standard replacement for it for quite a while. In fact, that standard replacement has been there since 1.4. Nonetheless, there are many libraries that still use the internal class. And the problem is all the Sun security packages are strongly encapsulated now. What does that imply in JDK 9? Well, in general, if your code uses JDK internal APIs, then it will not compile on JDK 9, and it may generate warnings at runtime. Now, wait a minute. You might be thinking, why won't I get errors at runtime, like you showed earlier for the secret class in confu-util? If I have a jar file built with JDK 8 that goes and tries to construct one of these X500 name things, why don't I get an error message like this? The answer is a lot of developers, deployers, and users just aren't ready. Migration takes time. Migration from bad habits especially can take time. So we've deliberately relaxed strong encapsulation of legacy JDK internal packages in JDK 9 at runtime only, so that old code will continue to work for a while. But I do mean for a while. Eventually, we want the JDK to enjoy all the benefits of strong encapsulation that I've mentioned earlier. So we will eventually re-strengthen that. So the addendum to this statement is, in a future release, code like this will not run. To help you get ready for that future, in JDK 9, there's a new tool called JDEPS that you can run on your own code. If you run JDEPS with the JDK internals flag against a jar file or a class file, it will go do some static analysis, figure out most uses of internal APIs, and suggest standard replacements if they're available. I highly recommend that you check it out. It's been a long road to Jigsaw. It's been a long road to design and deliver it. It will be a long road to its wide adoption, and that's perfectly fine. Many of you will make use of the newly modular nature of the platform long before you use the module system in your own code. Using module in new code is relatively straightforward. Modularizing existing code, however, can be a lot of effort, as we learned with the JDK itself. If you do modularize, Jigsaw does try to make it easier by providing tools to support both top-down and bottom-up migration. You can modularize your own applications before all of their dependencies have been modularized. And if you maintain a library or a framework, I encourage you to publish a modularized version of it as soon as you can, but not until all of its dependencies have been modularized from the bottom up. Jigsaw lays a strong foundation for the future of Java. It also supports the broader themes we've discussed here today. It's scalable, as we've seen. It's easier to evolve, and it's easier to evolve more nimbly. We can now remove entire obsolete modules. We can deliver new yet non-final APIs and incubator modules for early testing and feedback. And thanks to strong encapsulation, we can change the internals of the JDK whenever we need to. Jigsaw, of course, has been part of the open source JDK project developed in the OpenJDK community, so it's open as well. We received tons of valuable feedback along the way. Thank you, everyone who contributed good insights and experiences. And I'd also like to thank the long-term contributors to Jigsaw, who in some cases have been on this project for almost as long as I have. For more information, you can visit the Jigsaw project page in the OpenJDK community. There are links to all of the JEPs, the JDK enhancements proposals, and the JSR for the standard parts of the module system itself. My colleagues and I are giving a number of sessions this week. These are the times. They all happen to be in Moscone West Room 216. You'll notice that Prepared for JDK 9 by Alan Bateman was given this morning. There are likely to be repeats of all of these sessions. They just have not been scheduled yet. So pay attention to the online schedule, and you can probably still see it at some point. Alex Buckley will present the middle two, and I'll present the last two. For an even deeper dive, I highly recommend a new book just out from O'Reilly, Java 9 Modularity by Sander Mack and Paul Backer. It's a comprehensive and pragmatic guide to both the module system and the modular platform. And of course, there are other books that cover Jigsaw and 9, and they're either available now or will be very soon. So Jigsaw is here. It's part of Java 9, but it's not the only part. There are many other great features in 9, large and small. I'd like to show you a few of them right now. All right. So the first is JShell. I know I talked about it last year, but it's so cool, I just have to talk about it again. JShell is finally, Java has a redevelop print loop. Woohoo! You can type little expressions at it. You can declare variables and assign them values. It has tab completion. I hit tab right here, and it says, oh, there's a length method. You can invoke that. You can even show you the alternatives that you have at any given point. So here's substring, and now I can type 0,3 and just get foo. And you get the idea. JShell is extremely handy for just doing exploratory programming, figuring out what's going on before you write actual code. Is that going to work? No, of course it's not. Is that? Yes. And it's got history. See, you can go back. Actually saves your history for a long time. Here's stuff I did like 3 days ago. OK, that's cool. So another cool thing in Java 9 is collection factories. How many people wish Java had literals for collections? Yeah, it's a pretty common request, going back many years. Well, we thought about how to do that, and it turns out there's no great way to do it. But we now have collection factories that make this much more convenient. If you just need to create a little collection that's got constant content in your code today, what do? Well, you do something really boring, like arrays.as list of, you know, what do we do? Bar, you do this. You know, when you think about it, it's kind of stupid because it makes an array containing these two strings and then converts them to a list, and it's like, oh, well, that's dumb. Yeah, we can do that. What if you wanted to, what if you actually wanted to make a hash set? Well, you can do a new hash set. And yeah, that works. But oh, yeah, you wanted to make that unmodifiable because, well, it's a constant hash set. It shouldn't be modifiable. Collections dot unmodifiable set. Tab completion for the win. Now now it's unmodifiable. Even worse, suppose you wanted to make a map. How do you make how do you make a constant map? Well, there's no syntax for that. There's this really gross, dirty, ugly hack. Some people call it the double brace idiom. I'm going to show you this, but you have to promise not to use it. Oop. What did I do wrong? Oh, no. Oh, yeah, thanks. See? History is great. OK, I just made a hash map, but at what cost? I had to create, you know, there's an internal, there's an anonymous class created just for this purpose. Oh, geez, it's insane. So happily, we have a much better way to do this in Java 9. There are some convenience factories on the primary collection interfaces. I can now say list of. Ta-da, it makes me a list. I can say set of. I can even say map of, and there you go. Maybe not quite as slick as built-in language feature for it, but it's just about as good. Okay, another cool feature is JavaDoc search. You might have noticed that my browser got tripped up on this a little earlier. Let's go back to that JavaDoc page. JavaDoc now has a search box. You can type things up here. It doesn't talk to any servers. This is entirely in the browser. It shows that JavaScript actually is good for something. So suppose we wanted to see the JavaDoc of that map.of method that we just used. It does search ahead, tells you all the alternatives. You can see here, if you look carefully, how we implemented like the first 10 combinations as explicit methods, just to be efficient. But in the worst case, it'll take an array of elements. So map.of, click on that. Whoops, click on this, and boom, there you go. You can find entire modules. Suppose you wanted to learn about the new module, java.lang.module. Contains APIs specific to the module system. There you go. There's Java Lang module. You can scroll around in it, learn about what's in there. You can also, yeah, let's look at a couple of other modules. Oh, here's a popular module. So here's Corba. It's got its little graph. You can find out what things it exports, what things it requires. All that information is there. Now, something I'd like to point out about this is this annotation. The Corba module, as well as some others, have been deprecated in Java 9. We've enhanced the deprecated annotation to include a since value, identifies the release in which it was deprecated, and for removal. If for removal is true, that expresses the intent to remove this. So beware, Corba is on a limited lifespan. OK, could we switch back to the deck, please? Wrong device. OK, so that's just skimming the surface of some of what's in 9. Of course, to use 9, most people won't be like me and use Emacs in the command line. Most people will use an actual IDE. IntelliJ and Eclipse already support Java 9. NetBeans, I'm told, will support it pretty soon. To demonstrate how IntelliJ IDEA in particular supports Java 9, I'd like to welcome Eugene Petrenko from JetBrains. Hey, Eugene, what have you got for us?
Thank you for having me. So here I have a demo with IntelliJ, and currently I use IntelliJ 2017.3. This is an early access build, so anything can happen. OK, so this is a small application. It just prints hello world. It prints the version of the Java machine, and then it prints the module, which is associated with the class. As you know, in Java 9, any class is associated with the module.
Even if it's on the class path.
Yeah, exactly.
Yep.
So
a little tricky.
Yeah, and here have the really nice thing. This one is associated, this main class is associated with an unnamed module. And here's why. If we take a look closer on the command line, we see that IntelliJ still runs it with a class path. So exactly the same way as we tend to start our applications like for years. And to benefit from our modules, we need to turn this application into a modularized application. So for that, we can simply create the module info in the root of source folder, like this. So we call it some kind of org demo, for example. And in here, we have anything what we need, anything that we use to code completion. For example, it helps me to write anything I need, and so on. So if we turn back closely to my example, we have a compilation error over here. And the problem is that the MX beans are no longer in a Java.base.
They're over in some Java management module, right?
Yeah, right. So, and if we take a look on a highlight, so it shows us that we need to include this requirement to make it work. And instead of typing it manually, I can simply click here and say, please include it for me. And if we switch back, we see that there is now a requires that does the trick for us. So now let's start this application once more. So if I start it here, we see that the module of my main class is now exactly the same as specified over here. And if we take a look closer to the command line, what we have, we see that IntelliJ understands that this is a modularized application, so it uses the module path, -p for short, and a module to start it. That's it. And of course, dealing with one module is not that interesting, so let me switch to another example over here. So I have some more information here. And if it's tricky to understand what's going on here, I can just navigate between modules. For example, I can take a look into Java sources if I need some information or insight. For example, what packages it exports or what services it uses.
I recognize that module declaration.
Yeah. So, and if we need to take a look, like, from the height, how my dependencies are, so I can do this one. So in a diagram, I see that my module depends on some 3 modules. There are some transitive dependencies, some static dependencies. For example, I can navigate over here and see that a static requires, that is transitive requires, and so on. So, and for example, if I decided to add some more requirements for my application, say I decide to use like that one, I can switch back and take a look how it looks like now. And if you take a look closer to this source file, you see this highlighting. This is a really nice feature of Java 9, and it's an ability to say in a deprecated annotation that it's going to be removed. So it's kind of verbose thing that IntelliJ shows us.
IntelliJ is figuring that out and striking this out to think about using something else.
But of course it would compile, but still it's quite verbose now. And you see the error over here in the right top corner showing that there is a problem here.
Cool.
Cool. And I really like this one. I tend to write Java code for years. And if I need some unmodifiable...
Wait, I told you not to use that.
Oh, really? Sorry. I'm gonna fix it now.
Ooh,
does it look better now?
Refactoring.
Yeah.
Horrible idiom to a new API. Excellent.
Yeah.
OK, thank you very much, Eugene. That's great.
Thank you.
So Java 9 is here at long last. What comes next? To understand more about the future, let's take a brief look at the past. For 20 years, Java SE and the JDK have evolved in large, irregular, and somewhat unpredictable steps. Each release has had one or a few really big features, and the schedule of those releases has been adjusted as needed, sometimes more than once, in order to accommodate those big features. That's good for the big features. It gives them time to bake, but it's bad for the smaller features because that means it can take a long time to deliver them, even if they're ready long before the big features are finished. So we wind up with releases that are grand and majestic, but they're just rather slow-moving. For Java to remain competitive in this day and age, it must not just continue to move forward. It must move forward faster. That's why we've proposed doing a new feature release every 6 months on a strict, time-based model. In this model, features go in only when they're ready. If a feature misses the current release, that's OK, because it's only 6 months until the next one. It's not that big a deal. We think this is a good balance between fast enough to deliver innovation at a regular pace and slow enough to maintain a high level of quality. So the next feature release is 5 months away, March 2018. The one after that will be September 2018. The one after that will be March 2019. There will be a long-term support release every 3 years, starting in September of next year. So if features are going to go in only when they're ready, then we need a pipeline of features that we're working on so that when a release comes around, we can late bind to it and figure out, OK, what's ready? Let's put that in and ship it. We've been investing in that pipeline for years in the OpenJDK community. Here are some examples. Project Panama seeks to improve the connection between Java and native data and native code. Project Valhalla is about specialized generics and value types. Project Amber is about right-sizing language ceremony. And a new project, not yet proposed but being discussed right now, is Project Loom, which will aim to bring continuations and fibers to the Java platform to greatly simplify concurrent programming. To help us learn about one of these projects, please welcome Brian Goetz, our Java language architect.
Hey, Mark.
Hey, Brian. So, Project Amber, what do you mean exactly by right-sizing language ceremony?
Well, as you might have noticed, Java has a bit of a reputation for being a little bit boilerplate intensive. Maybe
Yeah.
it takes a little too much code to do a lot of common tasks. And so Project Amber is really a collection of smaller features that are aimed at reducing the overhead or the ceremony of things that we do every day, streamlining everyday coding, but also making code more readable and more reliable. And these are features that we can deliver over time, and I think a lot of them are a very good fit for the kind of programming models that are popular in the cloud, like the function as a service demo we saw earlier, or reactive event-based systems, like message-based systems or actors.
Right, right. So I know one of the sort of sub-projects of Amber is called local variable type inference.
Yeah.
What's that all about?
Okay, so local variable type inference is a feature that we've seen in a number of other languages. But before, Java's had type inference for many years, and we've used it in some places in the language, and we've expanded the set of places that we use type inference over time. Type inference is basically just the compiler figuring out the type of something without you having to write it down. It can make code more readable by getting unnecessary information out of the way. And so this next iteration is simply extending that to the way we declare local variables.
Mm-hmm. You have an example, I think?
Yeah, so here's some typical Java code. The way you have to declare things in Java is you say the type first and then the name. But one of the things that we've noticed is that, at least in well-written code, the name is actually more important than the type, because it talks about how that variable, what it means in your program, not across all programs. And so if we allow the compiler to infer the type for you, well, the effect that it has is to sort of bring the name more front and center and puts the more important information where we can see it.
Like this?
Like this, exactly. So almost the first thing you see are the names. And of course, if you pick bad variable names, then your code will be unreadable. But
I never pick.
I never do that either.
No. But this is not dynamic typing, right?
This is not dynamic typing. It's full static typing, the same static typing we've always had. It's just the compiler figuring out the type of thing from information that's already in your program.
Mm-hmm. Great. OK, when can we have this?
So it is already committed. This will be, this has been committed to the JDK 10 repositories. And should be shipping.
You mean 18.3?
18.3, yes, that.
Right.
And,
here's the actual commit message from last week, Maurizio's commit.
So it will be in a production release in March.
Excellent. That's very cool. So what else is going on in Amber?
OK, so the next thing I want to talk about is actually a much bigger feature, and it's a feature I'm really excited about. It's called pattern matching. So pattern matching is a feature that's been around, it's been associated historically with functional programming languages. And more recently, you've started to see object-oriented programming languages like C# and Scala adopt this feature as well. And we think it's a really good fit for Java. And so sort of to motivate why we think pattern matching is interesting, it has the ability to simplify the kind of code where you have to do multi-way conditional operations.
Right, code like this?
Code like this. So you're handed an object, whether it's a parameter or you've read it in from a socket, and it's going to be one of 10 different things, and if it's this, you do this, and if it's this, you do that. And this is how we write this code today. And on the one hand, there's nothing wrong with this code, because it's really kind of what you have to do. On the other hand, there's like everything wrong with this code, right? So it's verbose, right? It's repetitive. And the problem with repetitive code is it tends to be error prone. We do this by cut and paste. Was that a secret? Should I have not said that? Yeah, so we do this by cut and paste, and it's easy to make cut and paste errors. And the repetition is really overwhelming, right? So not only are we saying, are you an instance of this, are you an instance of that, but after we do an instance of test, what's the next thing we do?
We cast it.
We cast it. Like, what else were you going to do, right? So there's a lot of repetition in this code, and as a result, these are places for bugs to hide.
We can do better.
We can do a lot better. So morally, the code on the previous slide wanted to be a switch.
Yep.
But switch is really pretty limited. Switch can only switch on certain types. It can only compare against constants. And so, if we enhance the switch statement to deal with patterns, which is what we've done here, we can make this code a lot easier. So the new thing that's going on here are these case labels. They're not constants, they're patterns. And a pattern is a combination of an applicability test, are you an integer, with some kind of conditional operation that you're going to do if the test succeeds. Cast it to an integer and bind it to a fresh local variable, which in this case is called I.
Nice.
And so already the code is becoming more readable, and it's more obvious what's going on because we've eliminated a lot of the cruft. But you can still see there's still some repetition here. We're kind of doing this in a very roundabout way where, since a switch is a statement, not an expression, we have to make an assignment in every arm of the switch statement. And it's easy to forget to do that in one arm. And if your tests don't have good enough coverage, you just have a bug that's lying around. So we can make this example even better by turning switch into an expression.
Like this.
Right, exactly like this. And so now this is probably the code that you had in mind when you were writing the code on the first slide in the first place, but you couldn't write it like this, so you had to write it in this very roundabout way. So this is code that's more readable, more maintainable, much less error-prone, and as a bonus, faster, because the first code was a linear chain of tests, but by expressing it as a switch, the compiler can turn this into a decision tree, and it's probably going to be faster as well. So less verbose, less error-prone, faster.
Great.
Trifecta.
So patterns are cool, but these seem fairly somewhat limited. Can they be generalized to bigger cases?
Yeah. So this is a really simple example, but more commonly, when we're called upon to make a multi-way decision, we're handed complex objects, which we're going to destructure and take out their state and then do something with. So as an example, like let's say we have a hierarchy like this, where you have a shape and you have circle implements shape, and it has a center and a radius, and square implements shape, and it has a corner and an edge. And let's say we want to calculate the area of one of these things. So we know it's going to be one of these three things. We know we're going to have to take them apart. So we can use what are called destructuring patterns to rip through all the boilerplate that we would have had to write, right? I mean, so if we were writing this the old way, it would either be big, nested, ugly if-else, or even worse, visitors.
Yeah. Oh.
So pattern matching lets you express this in the sort of direct way that you want it in the first place. What we're saying is we're switch on the shape, and we're saying, is it a circle? If so, cast it to a circle, extract its center and radius properties, and then use that to compute an expression for the area of the circle, and similarly for the square, and similarly for the rectangle. So it's kind of saying what you mean without all of these layers of boilerplate.
Very nice. Now that's a much bigger thing than var, right? So it's going to take some time to do this. How are you going to do this, given that features are only going to be feature releases will only be 6 months apart?
So we're going to break it up into smaller pieces, right? The first example we showed with type test patterns, we can do that first, and then we can add more different kinds of patterns, more different places in the language to use patterns over time.
Although in a way it makes the job harder, because we have to be really sure that we're laying the foundation for the thing we ultimately want to do.
Yes, we do.
Yeah. All right. Thank you very much, Brian.
Thanks, Mark.
So Project Amber is just one example of the long-term investments we're making in Java. There are other large projects, not just the ones listed here, but many others. There's a continuous pipeline of smaller features that are smaller, but no less important. We hope that all of this work will not just keep Java moving forward, but moving forward faster. Thank you very much.
All right, thanks, Mark and Brian. Well, as promised, you got to see a lot of interesting things today, and there's a lot more interesting stuff to happen at the conference. One of these things I will mention tomorrow, there is the Oracle Code Keynote. It's at 4:15 at the Marriott Marquis, and you won't want to miss this. Patrick Dubois is generally regarded as one of the founders of modern DevOps, and Buster Benson is from Slack. Please go and check it out. It's free for all JavaOne attendees. Thanks, everyone, and enjoy JavaOne.